Let's consider some characteristics of covalent molecules. First of all, bond lengths. Three different types of covalent bonds. We have single bonds, double bonds, and triple bonds. Well, in terms of the length of those bonds, in other words, the distance between the two atoms that are bonding together, the single bonds are the longest bonds, triple bonds are the shortest bonds. Then we can also see that there's an inverse relationship between the length of a bond and the energy of a bond. A triple bond requires a lot of energy to form, and it also releases a lot of energy when it is broken. So the triple bonds are the strongest bonds, and the single bonds are the weakest bonds. We can also talk about covalent molecules and their geometries or shapes. So I have some diagrams here in the notes on the right. We can look at the shape of those molecules and their bond angles. So the first diagrams you see, hopefully pretty easy to notice or realize that those are linear molecules. The bond angles are 180 degrees. So the atoms in that molecule are separated by 180 degrees. We can get linear molecules or shapes when we have two atoms bonding together, three atoms bonding together, or even possibly four atoms bonding together can get us a linear shape as a possibility. We have to construct those molecules to be able to tell what shape they are. Now the next shape you see is a bent shape or an angular shape. These molecules have 104.5 degree bond angles. These will only form when you have three atoms that are bonding together. Another type of shape we see here is a trigonal planar shape. These have 120 degree bond angles. They consist of four atoms bonded together. The only way for the three atoms that are bonded to the central atom to arrange themselves in three-dimensional space is on the same plane and 120 degrees apart from each other. So if you see a little three-dimensional picture of that, there's a little GIF that shows that. The other two molecular shapes we will consider are trigonal pyramid. They have 107 degree bond angles. So this also occurs when there's four atoms bonded together. And in this case, the three atoms bonded to the central atom do not lie in the same plane. So they're slightly offset, and that's what gives the 107 degree bond angle. The last shape is called a tetrahedral. Tetrahedrals involve five atoms bonding together, and there are 109.5 degree bond angles between these atoms.